Let's solve this problem. They have given that logical address space equal to 256 KB. Now I am converting this in terms of powers of 2. 2 power 8 into 2 power 10 bytes, which is nothing but 2 power 18 bytes. Also they have given the page table entry size, which is 4 bytes, and I'm writing it as 2 power 2 bytes. Now the question is, what is the minimum size of page possible, assuming that we are using single level paging? See, they are asking what is the size of page, okay, minimum size of page. Now they have given that we should use single level paging. Now what do we mean by single level paging? Size of page table should be less than or equal to page size, right? See, in case if this is not true, then we cannot have single level paging, it will lead to multi-level paging. So since they have given that we are using single level paging, I am deriving the fact that page table size should definitely be less than or equal to page size. Fine. Now this, as you know, page table size can be written as number of page table entries into size of a single page table entry, right? And this should be less than or equal to page size. I am writing as it is. Fine. Let's see which are the data which we know. Okay. See, we need to find out what is the page size. They have given page table entry size, right? This is given. So I'm writing it. Fine. Do we know the number of page table entries? No, we don't know the number of page table entries, right? See, number of page table entries will always be equal to number of pages. You know that. So I can write it as number of pages, right? Now why am I doing that? You will understand the next step. Number of pages into 2 square should be less than or equal to page size. See, the same expression, I am writing number of pages instead of number of page table entries. Why? Because number of page table entries will always be equal to the number of pages. Fine. Now let us assume page size is P. Why? Because page size is what we wanted to compute, right? I am just assuming this is P. This is P and this is 2 square. Fine. Now what is the number of pages? See, number of pages is nothing but logical address space divided by page size, right? Number of pages is nothing but logical address space divided by page size. They have given logical address space, which is nothing but 2 power 18, right? Also they have given, they didn't give the page size, right? They didn't give the page size, but we have assumed page size is P, right? We have assumed that page size equal to P, so I am writing as it is, 2 power 18 divided by P. This is the total number of pages in our process, right? Now I am going to substitute this over here, number of pages, right? So it is nothing but 2 power 18 divided by P into 2 square is less than or equal to P. Now I am going to move this P over here, right? Now what will happen? 2 power 20 is less than or equal to P square. I can also write this as P square is greater than or equal to 2 power 20. I am taking square root on both sides. Okay. In that case, P will be greater than or equal to 2 power 10. Now, what is the unit for 2 power 10? See, what do you mean by P? P is nothing but page size, right? So, it is nothing but bytes. So the size of the page should be greater than or equal to 1024 bytes. As I keep on increasing the pages, number of pages will decrease, right? See, it is very important point. As we keep on increasing the page size, the number of pages will decrease in a process for a given logical address space. Let us assume this is our logical address space. Now in case if I take page size to be very small, number of pages will become more, right? Whereas in case for the same logical address space, that is important, for the same size of process, in case if I increase the page size, the number of pages will come down, right? That is what I am trying to say here. See, in case if the value of page size is greater than or equal to 1024 bytes, so in case if page size is greater than or equal to 1024 bytes, it is fine. We will have single level paging. Now, in case if I subtract p, in case if I reduce the value of p, which means in case if I reduce page size to be less than 1024 bytes, what will happen? As I keep on decreasing page size, number of pages will increase, right? If number of pages increase, what will happen? Number of page table entries will also increase. Why? Because number of pages will always be equal to number of page table entries. Now in case if number of pages increase, number of page table entries will also increase. Now if number of page table entries increases with a given page table entry size, which means we are going to maintain page table entry size as it is, and in case if we increase the number of page table entries, then size of page table will also increase, right? Now in case if size of page table increases, we will not be able to place the page table within a single frame, right? Now in case if you are not able to place the page table within a single frame, now what will happen? We might have to go for multi-level paging because we can't use single level paging. That is the problem here, but they have clearly given that we should use single level paging, right? So that's the reason I'm saying that the value of p, which means page size, should be greater than or equal to 1024 bytes. So the minimum value of page size is nothing but 1024 bytes, right? It can even be more than 1024 bytes, it is fine, but it should be greater than or equal to 1024 bytes. Now in case if I reduce page size to be less than 1024 bytes, then in case if I reduce the page size, then the number of pages will increase. If number of pages increases, number of page table entries will also increase. Now if number of page table entries increases, then page table size will increase. In case if page table size increases, I will not be able to place the page table within a single frame. Now in case if I am not able to do that, then I should definitely go for multi-level paging. Okay, that is what I want to tell you. So the minimum size of page is nothing but 1024 bytes. So the answer for this question is 1024 bytes.